Hey, what's up guys? Today we're working on this 256GB Lexar CFast 2.0 card. This device is a solid state drive that is used with the higher end cameras that can shoot really fast. This unit supports up to 540 megabytes speed, and whatever this card has we need to restore. Now PC3000 SSD supports this controller, and possibly we will resolve the issue with this card using the utility. However, prior to doing that, we need to go through thorough diagnostic process on this device to understand what the issue may be, whether it's corrosion, whether it's bad connection, or if it's something on a logical level that will need to be intervened with firmware work that is going to be helped with PC3000. So to do this work, we're gonna need this PC3000 portable, we're gonna need the Windows-based laptop, and we're gonna need the adapter that can support this type of a card, which I got right here. I bought it from Amazon. Prior to disassembling, we can obviously hook it up to an adapter and see what's going on. Alright, so we got this thing hooked up. This is the other end of the cable. It's gonna go in to our DeepSpar's box. Plug that in. Launch the USB control panel for DeepSpar USB stabilizer and power on our device. Let's just set it to be SSD. Well, seems like it mounted up and it wants to run. Let's open up our studio and see what we can visualize. There's our studio. Our device is going to be connected right here. It shows up for 1 gig. That's the problem. Our device is not 1 gigabyte in size. Our device is actually 256 gigs. And if we look in the hex view of this unit, what do we see? We see some factory settings of the controller, because this device is based on Silicon Motion 2246 controller, and every sector is going to display similar pattern all the way throughout. This means that our unit is in a safe mode. So right now I just wanted to run a brief test for the device. We got adapter with the failed unit hooked up to port 0, and we are currently located inside of the port 0. So let's go ahead and power things up. We got the LED come on the adapter, and the device shows us some ready status. Let's hit auto detection. It detects as a crucial, but it's not a big deal whether it's crucial or Lexar. They're both based on the same controller that is being pre-detected for us. I'm actually gonna go all clean on this one and go into select, manually selecting Lexar Silicon Motion utility, and we're gonna launch it. Now it gives us automatically some ID properties here and gives us controller type and the family, so we're gonna select that for the utility as well. The device is gonna try to upload a loader automatically. We can say yes, and now we just gotta wait until the loader is loaded up. Now this is unusual. This usually does not happen, but I have a suspicion why this happened just right now. So let's go into tests, and I want to see memory chips test performed. So over here we have our units, and we have 2 attention messages. So attention number 1, a specific number of chips, which is 8, does not correspond to the number of detected chips, 16. And that, I mean, I know that there's 4 chips, so I'm not really going to pay attention to this message right now. But we do have another message saying IDs of some chips are different. And if we look at the selection here, some of them are magenta and some of them are black. And if compared, we can see that where there's a D, we have a 5. So that's a problem. That's not supposed to be like that. Now, I don't think that can happen on the memory chip level and be consistent for all of them, all 4 of them. This would be super unusual. But if it's all related to the channel 0, and we can see that it is, channel is controlled by the controller. It's not controlled by the individual chip, it's controlled by the controller. So we have a problem on a controller level where the channel 0 for some reason gives us a wrong ID for all 4 chips. So let's go ahead and turn this off and pull the card out of there. And I'm going to take this card to the workstation for further inspection. This thing into the adapter, and on our screens, what do we see? We can power it up and perform the same test that we did before. But now we don't have any improper numbers there, right? So if we leave and go back in, let's say, and we want to start the utility and use the loader right away, this time it shouldn't throw any error messages like it did before. Instead, it loads up the device and proceeds with the CP table loading. Now this is going to take a little bit of time, and I'll put this on fast forward for you guys, because this will need to first of all upload the loader, then it's going to have to build a translator within the utility, and I'll show you how the data can be accessed in this state right now. Once I confirm that we have access to the device, I'll save the translator that we built, and I am going to remove the jumper that I put in place for the safe mode. And what that will do, it will actually take the safe mode off of it, and the device will be forced to go into a normal mode. Based on what I see here, I think the normal mode is going to do just fine all on its own at full speed, and the image can be captured fairly quickly. Using the utility feature on a device with degraded firmware is a must. It's the only way to communicate, as long as you got communication with all the chips. But if the device does not have a problem with firmware, and if you can bring it up to function by repairing it, then you can get into the normal mode and create an image using data extractor much quicker. So now that the translator is built, it only took about an hour for the device that's this big, and if this was, again, I gotta stress about it, if this was the only option to get access to the data, it doesn't seem too bad. So I'm gonna select active utility as the source for imaging, and the target is gonna be a file image. So we're just gonna dump it all into a file image, select OK, and start it up. So since the translator is already initiated and it's loaded into the utility, and we've selected the source to be the utility, nothing needs to be recalculated before the task starts. Now before we go into it, I just want to go back to the utility set, go into the tests, service information, translator, and I want to save it to a file for the task. So now it's going to save this binary data file as a translator, so next time we need to load it up, we can just select it from there. Now go back to the utility, we can go into the map, let's try to read it, enter first sector, and we get a successful read. Let's just scroll down to the bottom. Yeah, we can see that this is the correct sector. So let's go into the structure and see if we can maybe display the structure right away. To refresh, expand. Gonna go ahead and clone it for a little bit. Being able to access the content of this card with help of the utility is great. But let me see if I can maybe gain access directly to this card's content by removing the jumper that was set there to initiate the safe mode. There we can see in the corner the jumper has been removed. Plug the card back in. And power up the device. And some time passes, the device becomes ready. Let's go into the utility. And if we request passport, how do we do that here? Drive ID. We get proper ID with proper capacity, serial number, and everything. If we go into the sector edit, we can read the content from first sector without any issues. And we can go back, initiate a brand new task. This time we're not going to select the utility, we're going to select the actual SATA 0 channel and go next, 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 save it into a dump file, sure. It's going to tell us that this task already exists, so be it, we're going to overwrite the old task file. But this time we don't have we don't have the utilities information up here, we actually have the devices information up here. And if we fire up the image process, you can see that our speed is very good. 70 megabytes per second, I couldn't be more happy with that. You see this header here? When I first encountered the card with a similar situation, it was really strange to me, because I can see that the data is being produced properly, there are no errors, but for some reason cannot view or find any type of file structures. So after a thorough research, I found out that this specific camera records content using UDF file system. I believe it stands for Universal Disk Format. And if you look in the sector number 64, you'll see a specific signature for it, the one that I showed on the screen with BEA01, I think. So what happens is very interesting. Let's close this down. We did quick partition analysis. It does not detect any sorts of file systems that we can work with right away and start mapping the data out. But if I go into, let me go out of the vendor specific utility, and if I go back into the main view here, actually let's switch down to hard drive section. There is an option here to mount up the device as a disk. So we're gonna go here, open that, and I'm gonna just select it as a read-only mode and hit mount. And you see what happens right there on the screen right away. We get a pop-up with the folder, and we're ready to copy. So if you guys lost content on a CFast card, definitely check the link in the description, hit us up, let us know what's going on, and we'll help you out. If you have any questions, feel free to post them in the comment section below, but I think this was pretty good and detailed explanation on what could go down with the Lexar CFast 2.0 card when it's not getting recognized. Went through all the steps to troubleshoot, and everything should be fairly straightforward and easy to understand. If you guys new to this channel and you're interested in data recovery, don't forget to subscribe and hit the notification button to be notified when the next video comes out. I post regularly, and if you have any special requests, let me know what they are. Maybe we'll shoot the stuff that you like. Thank you very much for watching. I'll see you in the next episode.